Okay, so today we're looking at the product rule of probability. So our learning intention is the knowledge of the product rule and when to use it. So we will be successful if we can correctly understand what is meant by the terms multi-stage events, independent events, with or without replacement, as well as correctly apply the product rule to multi-stage events and to calculate the probabilities that we might be asked. So, let's look at these terms. A multi-stage event. This is where two or more outcomes happened together or subsequently. Yeah. So where, for example, we can flip a coin and then roll a dice. Or one event happens and then another event will follow. So often these can be displayed using a probability tree, or we could use a two-way table. Okay. An independent event, this is where the outcome of the first experiment does not impact the outcome of the second experiment. So for example, flipping a coin doesn't impact on the roll of the dice. Yeah. So where the first event, so these should actually be events, where the first event doesn't impact the second event because the overall situation is an experiment. Yeah. So this is the flip of a coin and top roll of a dice is an experiment. The flip of a coin is event A. The roll of the dice is event B. Okay. All right. Let's do some examples. We want to calculate the probability of rolling a number greater than 4 followed by landing on a head. So, numbers greater than 4, they include 5 and 6, and landing on a head, well, there's the sample here would be any heads and tails. So the probability of a number greater than 4 followed by followed by a head. Well, that's going to be the probability of a number greater than 4 multiplied by the probability of landing on a head. So we've only got 2 numbers out of 6 in this situation, and we've got 1 out of 2. So the probability of both events occurring is the probability of A occurring, event A, multiplied by probability of event B. So 2 times 1 is 2 over 12, which we can simplify to 1 over 6. Okay. So the product rule is if A and B are independent events in succession, then the probability of AB is equal to the probability of A multiplied by the probability of B. And that's the product rule. It can be written as the probability of number greater than 4 intersected with the probability of a head. Yeah. So the probability of A and B is the probability of A occurring multiplied by the probability of B occurring. Okay. Let's look at the next example. If a coin was flipped 3 times, we want to calculate the probability of landing on a head 3 times. Well, that's H. Well, that's just a half, the first event, times it by a half, times it by a half again. So we get 1 over 8. The probability of getting no heads is the same as basically getting probability of just 3 tails. Yeah, so it's saying it's probably getting no heads. So probably of sorry, that's not correct because that will also allow me to do heads, tails, or the combination of both. So it's no heads will be a probability of tail. So that's going to be the same, a half times a half times a half, or half to the power of 3 is 1 over 8. The probability of at least one head, well, that would be the complement of not getting at least 3 tails. Yeah, so that means if I don't get 3 tails, I could possibly have 1 head, I could have 2 heads, or I could have 3 heads. So at least 1 head. So that's going to be 1 minus 1 over 8, which is going to be 7 over 8. Note the difference. So no heads versus at least 1 head. So no heads was tails, tails, tails. Where at least 1 head was the complement of not having 3 tails. So if A1 and A2 and A3 are multi-stage events where each event is independent, so it doesn't impact the outcome of the successive event, then the probability of the event is a probability of the 3 situations, of however many situations you have, multiplied together. Okay. Let's look at 2 more examples. A jar contained 12 blue counters and 10 yellow counters. What's the probability of selecting without replacement 3 blue counters? So we're getting blue counter, blue, blue. So I start with 12 blue counters, and I have 22 counters altogether. I'm going to multiply. If I take blue at the first one, I'm only actually going to have 21 counters remaining in the jar. But because I've taken 1 blue one, I'm going to have 11 blue left. Because without replacement means I'm not putting the counter back in. If it was with replacement, that means I was putting the counter back in. It would be 12 over 22, and it would have 22 counters all at each time I carry out the event. But in this situation, it's without replacement, so the counters stay out of the jar once I've taken them. So I've taken out 2 counters. I should only have 20 counters in the jar left. If I got 12 to start with, I got 1 blue, got another blue, so I only have 10 more blue counters there. So 12 lots of 22, so times 11 over 21 times 10 over 20, I get 1/7. Okay. The probability of 2 yellow and 1 blue. Okay. So this situation means I could have yellow, yellow, blue. I could have yellow, blue, yellow, or blue, yellow, yellow. Yeah. So if I was to do yellow, yellow, blue, I would have 10 over 22. Then I would have 9 over 21. And then I would have 12 blue counters over 20. That's for that part. If I had yellow, blue, yellow, that would be 10 over 22, 12 over 21, and the 9 over 20. So if I got blue first, that would be 12 over 22. Yellow second would be 10 over 21. And then yellow last would be 9 over 20. Okay, so notice that I've actually got 3 possibilities, but all individual possibilities, or individual lines. Yeah, so here I've got 10, 9, and 12, 22, 21, 20. I've got 10, 12, 9, 22, 21, 20, 12, 10, 9, 22, 21, 20. Yeah, because we're multiplying fractions, when we multiply the numerators and then multiply the denominators, what we actually have is got 3 loads of 10, 9, and 12 over 22 times 21 times 20. Alternatively, you could have multiplied that plus the multiplication of that plus the multiplication of this. Yep. So the solution, so if I did 10, 9, and 12, doesn't matter because 10 times 9 is the same as 9 times 10, or 9 times 12 is the same as 12 times 9. It doesn't matter the order that you do. 20, 21, 22. So I times that by 3, I get the probability of 27 over 77. Okay. So if I wanted blue, yellow, blue, okay, well then that was 12 over 22 times 10 over 21 times 11 over 20. So 12 over 22 times 10 times 11 on the top, 22 times 21 times 20, I get 1/7. Okay. Let's do a last example. So we have a coin is weighted so that it is twice as likely to fall heads as it is tails. What is the probability of landing on a head? Well, if it's twice as likely, I've actually now have 3 possible solutions where 2 of them would be the heads. And the probability of landing on a tail would be a third. Okay. So if the coin was flipped 3 times, what is the probability of 3 heads? That's P, H, H, H. Well, that's 2/3 times 2/3 times 2/3, which is the same as 2/3 to the power of 3, which is 8 over 27. Okay. 3 tails, well, that's probability of tails is a third times 1/3 the second event times the third event, which is the same as 1/3 over to the power 3, which is 1 over 27. Okay, probability of heads, tails, and heads in that order. So H, T, H. So the first would be 2/3. The tail would be 1/3. Event A didn't affect event B, C, so it's still going to be 2/3 for heads. So that's going to be 4 over 27. Okay. So looking back, we need to know what a multi-stage event is. So all those examples that we've gone through are all multi-stage events, independent events, where the outcome of the first event doesn't impact the second, and the only time that affected it was this this example of the jar. Yeah, so without replacement, and that's what we talk about with without replacement. Correctly apply the product rule. So the product rule, as a reminder, if they're independent events, the probability of AB is the probability of A multiplied by the probability of B, or the intersection of A and B is the probability of A occurring multiplied by the probability of B, and that is the product rule. Good luck. Thank you.